Alright, shouldn't be too long, this video. I've just got 4 kind of unique quadratics to solve. So, well, they're not that unique. These 4 are actually all in the same form. Something squared equals a square number, something squared equals a square number, something squared equals a square number, something squared equals a square number. I'm just going to recap our normal quadratic solving skills for these, and then I've rewritten them, and I'm going to go through a more unique approach. So the standard way of solving a quadratic is we expand everything out and make it equal 0. So expanding this would have x squared minus 2x plus 1 equals 100. Subtracting 100 would make this equal 0. And now I need numbers that multiply to negative 99 and add to negative 2. So that's going to be negative 11 and positive 9. X minus 11, x plus 9 equals 0, and there are your 2 solutions. X equals 11 is the solution, x equals negative 9 is the solution. Okay, so what we could do with this one is very similar. Let's just expand this bracket out, so that's just going to be 4x squared equals 4. Okay, let's make it equal 0, so that 4x squared minus 4 equals 0, and we have got a common factor of 4 here. So we could divide everything out by 4. So that x squared minus 1 is equal to 0 divided by 4 is also 0. And now we've got the difference of 2 squares. So x plus 1, x minus 1 equals 0. There's your 2 solutions. X equals 1, x equals negative 1. X equals 1, x equals negative 1. Okay, you're starting to get the picture, so I'll go through this one quite quickly. Expanding, x squared plus 8x plus 16 is equal to 36. Subtract 36, x squared plus 8x minus 20 is equal to 0. Now we can factorize and solve. X plus 10, x minus 2 is 0. X equals 2 is the solution. X equals minus 10 is the solution. We're done. Okay. I'm going to do this one in a more unique approach to 2. Okay. Because like I say, there's a lot of tools in your tool belt for dealing with mathematical problems. So I like to kind of show different ways as well, especially when it's a recap video. So let's expand this. That's just 9x squared, because it's just one thing squared, and that equals 36. Okay, so we have 9x squared minus 36 equals 0. Now I could go about this 2 ways. I could divide everything up by 9. X squared minus 4 equals 0. Right, so x minus 2, x plus 2. Or, so that's one way. Or I could take the 9 out as a common factor. 9 lots of x squared minus 4 equals 0. So 9 lots of x minus 2, x plus 2 is equal to 0. Or, another unique approach is that it's the difference of 2 squares. So that's 3x minus 6 and 3x plus 6. If you were to factorize that as difference of 2 squares, which would leave a solution of 6 over 3, 2, and negative 6 over 3, which is negative 2, which is the same as solving this first way and the second way. So there's your 2 solutions. So that's just your standard expand it out, make it equal 0 and solve with factorization. But let's have a look at another way of doing it. Okay, square rooting both sides would give x minus 1 equals 10. But x minus 1 would also equal negative 10. So the square root of something squared is just that, something, so x minus 1. But the square root of 100 is the positive root and the negative root of 100. So adding 1, x equals 11, and adding 1 to negative 10 is negative 9, which is exactly what we got the first time we did it, 11 and negative 9. So if we were to square root both sides of this, 2x would equal positive 2, but 2x would also equal negative 2, because both those numbers square to 4. Dividing by 2 x is 1, and divide by 2, x is negative 1. And again, that's what we got the first time we did those problems. Question 3. Yep, you're hopefully picking up on the pattern. Square root both sides, since it's just something squared equals something. So x plus 4 is equal to positive 6. X plus 4 is also equal to negative 6. So x equals 2 when you subtract 4, and x equals negative 10 when you subtract 4. Is that what we got? Actually, subtracting 4, yep, 2 and negative 10. By your rubbish truck going past. Alright, let's square root both sides. 3x is equal to positive 6. 3x is also equal to negative 6, which is actually what we did in this part of the problem. Alright, so divide by 3 and we get 2. Divide by 3 and we get negative 2. Same thing. So that's another unique approach to solving quadratics that are in this squared equals, squared equals, squared equals form.